Okay, YouTube, this is my third video on sketching transformations of exponential functions, in which we're going to look at a little bit more complex transformations, including reflections and stretching and shrinking. But essentially, we're going to take a look at these two that you see here. And so what we're going to do is describe the transformation of f represented by g. And so remember that f, we typically use f to represent the parent function, and I write quotation marks because f of x is going to be our given function and g of x is going to be some transformation of f. And so just to be clear on this, our g of x is a transformation of f of x, whatever the given function is. And so what we're going to do is identify the transformations and then just graph both functions efficiently, hopefully here. And so we'd say in this first example we have f of x equals 3 to the x power. And so we can see that this is our parent function here. And the reason why we know this is our parent function is because recall that we'd say that y equals a times b to the x minus h plus k is our general transformation. Our parent function is just the b to the x form of that function. So we say y equals 3 to the x. If we're going to go ahead and look at how this is different from g of x over here, my favorite part about this video is because I just want to kind of ignore horizontal stretching and shrinking for now until we get the hang of vertical and all the other reflections. We're going to get rid of this coefficient of x, which really, by multiplying by 3, we would have had a horizontal shrink by a factor of a third. So I'll disclose that right now. But in terms of what I want to be able to do, I just want to see that this here would just be a transformation of f of x in that it has an h value up here hanging out with its x value. And so we would say that in this case, h is really equal to a positive 5, which means identifying this is going to shift right 5 units. And so now that we've identified this, we're going to throw these graphs together pretty quickly, starting with graphing the parent function. So our parent function, 3 to the power of x here, we would see that it would have a horizontal asymptote, of course, on the x-axis at y equals 0. It would have to go through 0, 1, okay, 0, 1, and then 1 comma whatever the base is. Now our base, in this case, our base is 3. So we're going to say 1 comma 3, and this would definitely be growth. And so throwing these on there, also one more thing I want to do is make sure that we get a third point. So we say 0, 1, 1, 3. We'll put in negative 1. We should get 1/3 here. And so 1/3 would be here. We're going to go ahead and label that point as well. We say negative 1 comma 1/3. What we're going to be doing is taking this original parent function, and it seems that because of our h value here, shift everybody right 5 units. So the way this works is that everybody, including the asymptote, shifts right 5 units. Fabulous thing about this is because the horizontal asymptote shifts right 5, it'll still be on the x-axis. So we'd say that y equals 0 will be both the equation of our original parent function's horizontal asymptote as well as our transformation's horizontal asymptote. And then looking at all of these points here, essentially because all we're doing is shifting them right 5 units, we're going to add 5 onto all of the x values. So instead of 1, 3 here, we're going to go 1, 2, 3, 4, 5, drop in this new point, but also call it what it is, which is now we went right 5 units, this would be 6, 3. Also, we'd say 0, 1, if we go right 5, we would say that this is 5, 1. And then also go right 5 from negative 1 comma 1/3, it'd be 4 comma 1/3. I'll go ahead and put this in here. We say 4 comma 1/3 would be on our transformation. And then using the same asymptote here, we would say that this is the graph of f of x, okay? This is the graph of our transformation. So we've identified what is different about it, sketch the parent function, and then go sketch the transformation. In the second example here, okay, we're going to be looking at some reflections. And so the interesting part about this is, I want you to understand that f of x here, this is supposed to be our parent function, and that g of x is our transformation of f of x. And so we could see some things here. For certain, we could see that the difference between what we have on the left and on the right here is that the a value out in front is equal to 1/2. So what we're going to see is that we have vertical shrink by a factor, okay, of 1/8. So all of our y values are going to be multiplied by 1/8. What we need to do, though, first is work on getting this graph of e to the negative x. And so the interesting thing about e to the negative x is that I'm going to name a different function here, h of x, and say that this is the even more parent function of this parent function, given function, at least that is here. Because we're going to say, ignoring this coefficient of x here, just making it positive, our base to the power of x is our parent function. And so something like this, okay, of course, would look like this graph here where it has an asymptote at y equals 0. It would go through 0, 1, and 1 comma e. We would get this graph that looks like this right here. Okay, and so here's our parent h of x function that I've named h of x, what we'd see from this would be the fact that because we have a negative in front of our x value, we're going to reflect everything over the y-axis. And so what we get now is this new function where this is going to pop over here. I'm going to specifically name this point. We're going to name this -1, comma e. We're going to name this one still 0, 1. But whereas this graph over here would have gone through -1, comma e to the -1, which is 1 over e, this graph now would become +1, +1. After we reflect it, +1, 1 over e. And so our parent function, e to the -x, let's go ahead and label this here. Okay, this is our f of x, this right here. And so f of x, what you can see is this graph of e to the -x, so our reflected over the y-axis e to the x function. So here's e to the x, here's e to the -x, decay. We're going to take everything here times a 1/8. And also what I want you to notice is that a is negative here. And so because a is negative, okay, this is the same as making y negative. And so what do we know about making y negative? It is an x-axis reflection. And so what we're going to do here is we're going to apply both of these transformations. It's not going to matter what order we do this in. That is to say that if we were to take all the points on f of x here and crush them down to be at 1/8 of their original height, we get this really flat graph here. And then reflect it over the x-axis where it kind of comes upward but really flat. Well, then what if we flipped it over the x-axis right now? So it came up like this, but at the same time, then flatten it out, we get the same thing. So in terms of our points here, what we're going to see is we're going to reflect it over the x-axis. So I'll start with that here and maybe in red. We're going to say that we have this point here, 0, -1, okay, and then -1, comma -e. So this would be our reflected over the x-axis graph. And so what I'm going to have to do is I'm going to have to switch my colors again here. Go over to maybe like a purple. Why not? Purple's a good color. Actually, we've already done blue. Let's do green. So green, and actually I'm going to label all these points in red here. I should have saved the red for those points. You guys, here's what these are. We said -1, comma -e, okay? And then we had 0, comma -1. And then this point here was 1, comma, and this is now -1 over e. And so what we're going to do with all of these now is going to take all of our y values times an 1/8, which makes this really fun because what we get is this. If our original points are 1, comma -1 over e, which is this point here, okay, this point. And our other point here is 0, -1. And this point here, -1, comma -e. If we take all of these times an 1/8 on our y value, we get 1, comma, this would be -1 over 8e. This would be 0, comma -1/8, and this would be -1, comma 1/8 times -e is -e over 8. And so we can get decimals on these, and that's, as a matter of fact, what I would prefer to do. So let's go ahead and do that here. If we said, I'll turn my calculator on here, we would get -1, that's a -1, so we say -1 divided by 8e, so I'm going to do 8, and then I have to do, unfortunately, e to the first because it only talks in bases there. Oops, get that extra parenthesis out of there. We would get this decimal here, -0.339. So -0.339, so this is 1, comma, -0.339, this here. We would say 0, comma -1/8, this is 0, comma -0.125. I got you on that one, I know that one. And then this last one here, -1, and we'd say -e over 8. We'd say, well, -e over 8, let's take -e to the first, so that gets us e, and divide that by 8. Suppose we would get -0.339 again. So we would say that's, you know what I did on my first calculation there. Let me pull that back up. Sorry to annoy everybody here. That first calculation, what I was missing, well, I'll type it in manually. We say -1 divided by, in parentheses, 8 e to the first. That's why I had an extra parenthesis there. That's better, -0.045. So this is -0.045. And then this here would be that 0.339. So we say -1, comma negative 0.339. So we get to graph all these now. But all these transformations lead us to this new graph. We say 1 comma really close to the x-axis, but negative we would say is be here. We would say now 1 comma negative 1/8 is negative 1.25. It's pretty crowded, but it's really close to 0 here. And then negative 1 comma negative about 1/3. So negative 1 comma negative 1/3. What we get is this really elongated, okay, graph, exponential graph here that comes up from the bottom side, and we'd say that this is our g of x right here. So I would say most importantly, okay, that you can label these points in the first place. You might have to use more than one grid, but you're going to have to apply several different transformations to these in the first place. But be able to graph the parent function first and identify what's going to happen first, and then go ahead and make those transformations happen, changing your points as you go. Cheers.